Hello world! Welcome to Learning Java, one byte at a time. This is video 30 in a tutorial series geared at bringing the wonderful wide world of Java to those with little or no programming experience. This video is a continuation of the development of the Booker application, a vehicle appraisal app. In the last video, we finished writing the utility advertisement class and the luxury advertisement class. Along with the sports advertisement class, we used a unit test to ensure the advertisement factory was correctly returning the instance of each one of those based on the criteria given. And it looks like everything's working correctly, so now we can move forward and begin to construct the DAO class and the DataStore class. Now, the DAO class is the data access object, and it's going to be the class in charge of directly interacting with the DataStore class. And our DataStore class is going to proxy as a database. Under normal professional conditions, you'd want to use a database to store or retrieve any sorts of files or information. However, that's a little outside the scope of this project, so we're going to use a DataStore class to proxy as that. The data access object acts as that extra layer of both protection and ease of scale, in that if you wanted to make any sorts of changes to the types of files being stored or retrieved, adding or deleting or modifying the extensions, having a data access object makes sure it ensures that there's only one file, one class file that you'll have to make those changes to, rather than sorting through all of the different access points to the database itself and trying to make the changes hard-coded. Additionally, it adds that extra layer of security so that none of the class files have direct access to the database. They have to go through the data access object, and this prevents anybody from malicious intent from querying or storing data into the database from their own means. And so jumping into the Notepad++ app, we can begin to construct the DAO class. And you see here I have a saved file called dao.java. Let's first ensure that it is properly included in the correct package, and then we'll declare it as a public class called DAO. So in the data access object, we're going to use a design pattern known as Singleton, and the Singleton design pattern is based on the idea of creating only a single instance of that object throughout the entire lifecycle of the application, and using that one instance as the access point to the class. The reason being is that we know that we're only going to need one DAO object, and so preventing any of the class files from creating multiple copies of this object will both save on memory and efficiency, and also give us a tighter control point for the access to the data. So the Singleton design pattern operates as follows. Normally, you'd want to have the constructor listed as public. However, with the Singleton pattern, we're going to define the constructor as being private, and that's going to be a private DAO. And the private DAO is simply going to be a constructor that returns nothing. It doesn't instantiate or return anything. It simply returns an instance of the object. And then what we're going to do is we're going to define a field, which is going to be a private static DAO object, and we're going to name it instance. We're going to set this equal to a new occurrence of the DAO object, and since this is within the same class file, it does have access to that private constructor. Next, what we're going to do is we're going to declare a public method called getDAOInstance, and it's going to return a DAO object. The getInstance method is simply going to return a DAO instance field, like so. And so what we're looking at is a private constructor that returns an instance of the object that can't be accessed from any other class file. We have a private field, which is a DAO object known as instance, and as soon as the class is called, it's going to instantiate that from its own constructor, which is private and has only access to it from itself. And then anytime that we are going to need a DAO object, rather than try to construct it from a class file, we're simply going to access this public method, which returns a DAO object called getDAOInstance, and that's going to return an instance of the field, the DAO object that we've set up here. This keeps everything not only encapsulated, but it ensures that there is no way that more than one DAO object can be created, and that's how the Singleton design pattern works. So now moving forward, we're going to need to have a couple of methods here. So we know for sure that whenever we return the file information, it's going to be returned in an array list of strings. So let's declare a public static array list of type string, and we'll name it load data. And it's going to need a file name, so we'll accept as an argument, we'll have a parameter called string file name. And what this is going to do is it's going to return an instance of accessing the data store, a method that we'll write called load data, and we'll pass through to the data store the file name provided. This is that extra layer of protection that we were looking for to keep other class files from having direct access to the data store. Next, we know that we're going to need to have the ability to save data, and we should save data much the same way that we load data in the form of a string array. However, rather than using an array list, since we're not going to need to make any sorts of manipulations or traverse it the same way, we're simply going to store it as a string array. So we'll do that with a public static. We're going to make this Boolean because in writing the further class files, we want to make sure that this passed or not. So we're going to return a Boolean value as to whether or not it worked. We'll call it save data, and we're going to pass through a string array that we'll call data, and then we'll pass through a string itself known as the file name. And this is going to return an instance of DataStore.SaveData. And we'll ensure that in writing the data store that we return a Boolean from there. So the data store, after saving the data, will return a true if it was successful and a false if it wasn't. And that in turn will be returned here whenever other class files call the save data from the DAO object. So we'll save data, we'll pass through the data and the file name, like so. Easy peasy. Next, what I want to do is I want to write a short method to see if the file exists. And this is going to be so that other class files can query the DAO object to see if the file is even present. So we'll do a public static Boolean, and we'll call it file exists. It's going to accept a string called file name, and it in turn is going to check to see if the data store file exists, and we'll write the file exists method in the data store, passing through the file name. And if the file doesn't exist, we're going to return false, like so. All right, so that's good and easy, and that is actually the entire DAO object that we need to write, or the DAO class that we need to write. Just those three simple methods. A method to load data, a method to save data, and then a method that will check to see if the file exists. And all three of these methods, you can see, make direct calls to the DataStore class, which we will now write. So we know that in writing the DataStore class, we're going to, at the minimum, have to write the three methods: load data, save data, and file exists. One is going to return an array list of strings. One is going to, the other two are going to return Boolean values if the save was successful or whether or not the file exists. And so let's go ahead and open up a new file, and we'll save this as datastore.java, like so. All right, so now the data store is going to be not very complicated. It's going to need to, it's going to involve some sorts of file streams. So we're going to have to do a couple of imports and a couple of interesting object creations with files. So let's first include it in the correct package. And we'll go ahead and declare the class data store. And let's go ahead and declare a scanner because we're going to need to traverse the files coming back. So we're going to need a scanner object. So let's create a private static scanner that we'll call in and set it equal to a new scanner instance of system.in, like so. Now, let's first write our file exists method. This is going to be a public static Boolean called file exists. It's going to accept a string called file. All right, so now we're going to use the file object, and we'll name it mfile. We'll set it equal to a new file of the name that we're passing through. And then we're simply going to do a check. If mfile.exists, which is a method from the file that we're going to actually have to import, we'll return true. And if it doesn't, then we'll return false. So these two booleans are going to be returned to the DAO class that makes a call to the file exists method. And so this true or false will be returned to here, and this true or false will then be returned to any other class in our package that's going to be making a call to see if the file exists. Again, that nice extra layer of protection and encapsulation. Okay, so before I forget, let's go ahead and make the import because we know we're going to be accessing the file object. So let's import java.io.file and see if there's any other imports. You know what? We're going to need to make a few imports. So let's import file. We're going to have some. We're going to have to do some try-catch blocks, or we're going to have to do some error handling. So let's do java.io.file.not.found exception, so we can throw the exception if the file's not there. We're going to have to import a file writer and a file reader. So let's import java.io.filewriter. We'll import java.io.io exception because that's the other exception that can be thrown whenever we're having any sorts of inputs or outputs. We're going to need to import, it's going to be actually under the utility package, the array list. And speaking of that, we're going to need to import the array list in the DAO class as well. We'll get back to that. We'll import our scanner object. I believe that's under utility, java.util.scanner, like so. All right, I think that's all the imports we're going to need to make. But before I forget, let's jump back to our DAO class and make sure that we have imported our array list. If I can type. Okay, we'll save that. So that DAO class truly is finished now. All right, and so we have all of our necessary imports. We have our scanner object declared and instantiated. We've written the file exists method, so now we have only the other two methods to write, which will be the load data and save data. So let's get to work on that. We'll start with the save data. That's going to be a public static boolean called save data. It'll accept an array of strings that we'll call data, and it will accept a string that we'll call file. And this is going to need to do some error handling, so we're going to need to do a try-catch block because there's two different exceptions that can be thrown, the file not found, or rather just one exception that can be thrown, the input-output exception. So we're going to try to instantiate a file writer called writer equal to a new file writer and pass through the file name file that we have used as the argument when calling the method. And if that works, we'll return true. And if it doesn't work, and if it doesn't work, we're going to catch the IO exception that could happen. We'll name it E. I can't type today. And we'll simply print that to the stack trace until we know what else to do with that. And of course, we'll have to return false because the save was not successful. All right, that should be everything we need with that method. Let's get this properly indented. Like so. Okay, so if we're able to do that, what we're going to need to do is we're going to need to traverse the string array, and for the length of the string array is going to be how many times we're going to make a loop, and we're going to write to the data object whatever data is in that iteration of the string array. So let's do a for int I equals 0, and as long as I is less than data.length, we'll increment I and perform the following, which will be writer.write whatever the data is in index position of I, plus, for formatting purposes, a new line. So we'll use the new line character to make that carriage return. And I believe that's everything we're going to need for that. This looks pretty complete. So if it does make it through that, it'll return true. Otherwise, it will throw an IO exception. We'll print that exception to the stack trace and we'll return false. So that looks pretty good for the save data method. So now let's go ahead and create our load data method. So this will also be a public static. This one's going to return an array list of type string, as we already know. And we'll call it load data. And this will accept a string called file. Now in this method, we'll declare the array list. We'll name it data. We'll set it equal to a new array list. And we'll also need a try catch block here. So let's try something and catch a file not found exception that we'll name E. And we'll print that exception to the stack trace. Okay, so in the try, let's declare a file called mfile. We'll set it equal to a new file object, and we'll pass through file as the file name. And then we're going to do if, and we're actually going to call our own method. If mfile exists, then we have potentially a file that we might overwrite. So we need to do in equals new scanner of mfile, and then we'll iterate using a while loop in this case. So while in dot has next line, so while there's still data there to be read, we will take that data and we'll add it to the array list of strings that we've instantiated known as data. So we'll add in dot next line, like so. We don't need that. Okay, so after we've done that, we will catch whatever file not found exception might be thrown. We'll print that to the stack trace, and then we're going to return the data, which is the string array that's being expected to be returned. Let me take a quick look at this to make sure this looks right. So we do have the array list of strings instantiated called data. We're going to try to create a file object called mfile. We're going to set it equal to a new creation of a file object and pass through the file name as the parameter, as the argument. If this exists, so if that file is actually there to be found and loaded, then we'll set in equal to a new instance of the scanner, and we're going to pass through mfile as the scanner because that's what we want to scan. We'll have a while loop that checks to see that it has more data to be read. So if in has next line, then we will add that next line to the data array. And then after all of that's done, if no error is thrown, we're going to return that data array. Otherwise, if there is a file not found exception, we will print that to the stack trace. And we will still return the array, but the array in that case will be empty. All right, so this actually looks pretty complete. I think that this does it for the DataStore class, the Data Access Object class, so both of these look pretty good. The video has gotten pretty lengthy at this point, so I believe this would be a good point to end the video. We'll come back for the next video. We'll write the unit test to make sure that this is working correctly. Just like always, the entire project is going to be accessible on GitHub in a link in the description. Questions and comments are always welcome. Hope that this video has been fun and educating. I look forward to seeing everyone back in the next video. Thank you so much and have a wonderful day.